start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So for us to get the remainder after we are dividing by an expression of the form ax plus b, we can use what we call the remainder theorem, right? But first of all, what do we know? We know that if f of x, if a polynomial f of x is divided by x minus a, right, for us to get whatever quotient that we get, we know that f of x would be equal to the quotient multiplied by the divisor, which is x minus a, then plus the remainder, right? But now when x, if we say when x is equal to a, we see that we've got the quotient. So when x is equal to a, this will be f of a. The quotient will be f the quotient times a minus a, because remember x is now equal to a, then plus the remainder, right? And a minus a gives us 0. So f of a will be equal to the remainder. Right? F of a will be equal to the remainder. So basically, when a polynomial f of x is divided by x minus a, the remainder is f of a. Right? And when a polynomial f of x is divided by ax minus b, the remainder is f of b over a. Right? And this b over a, we are simply saying from ax minus b, if we let it be equal to 0, and so for x, we're saying ax is equal to b, and x is b over a. So in place of x, we've got b over a. So now I would like to use this remainder theorem to solve those questions. So allow me to use this part here. Okay, so for number 1a, find the remainder when 2x to the power of 3 plus 8x squared minus 4x. So a minus x plus 4 is divided by x minus 3. So we've got x minus 3 as the divisor. But we say that if we let this be equal to 0, x will be equal to 3. Such that f of 3 should give us the remainder, right? So in this case, our a is 3, and f of 3 should give us the remainder. So we're simply saying, in place of x, if this was our f of x, say f of x being equal to 2x to the power of 3 plus 8x squared minus x plus 4. In place of x, we're now putting 3. So it will be 2 times 3 to the power of 3 plus 8 times 3 squared minus 3 plus 4. This will be 27 times 2 to give us 54. So 54 and 3 squared, that's 9. 9 times 8, 72. And 4 minus 3 plus 1. Right, and the result that we get here, let's simply say plus 73. So that will be 7, 123. Right, sorry, 127. So 127 is the result that we get. In other words, this is the remainder. And then now for part B, we're told that x to the power of 3 plus 4x squared plus 8x minus 3 is divided by 2x squared plus 1. And we're asked to find the remainder. So we don't necessarily have to carry out the whole long division process, because we know that the remainder theorem states that if we're dividing by a factor 2x plus 1, right? So we're simply saying for 2x plus 1, erase this part here, right? So we're saying for 2x plus 1, if we let this be equal to 0, x will be minus 1 over 2, such that if f of x is equal to x to the power of 3 plus 4x squared plus 8x minus 3, then f of minus half should give us the remainder, which is minus half to the power of 3 plus 4 times minus half squared, then plus 8 times minus half, then minus 3. And this will be minus 1 over 8, minus 1 over 8 plus 1 right? And minus 4 minus 3. And let's see what we get here. So this would be minus 1 over 8 plus 1 minus 4 and then minus 3. And then that will give us minus 6 and 1 over 8, which is 49 over 8, I think. Yes, minus 49 over 8. So this is the remainder that we get, minus 6 and 1 over 8 for part number 1, part B. Now let's move on to number 2. Number 2 says the polynomial 3x to the power of 3 plus ax squared plus bx plus 1, where a and b are constants, is denoted by p of x. So first step here, if we were to write p of x being equal to x to the power of 3 plus ax squared plus bx plus 1. And then when px is divided by x minus 2, the remainder is 9. So here we see that our a is 2. So we're saying f of 2 is equal to 9, right? And when p of x is divided by x plus 3, in this case, our a is minus 3. So p, why am I saying f here? Sorry, it's p. So p of minus 3 is equal to 19 there. And now we are asked to find the values of a and b. Given this information, right? P of 2 is equal to 9 and p of minus 3 is equal to 19. So now let's do the substitutions. Let's start off with this one. P of 2 giving us 9, we're saying 2 to the power of 3 plus a times 2 squared plus b times 2 plus 1 should give us 9. Says that 8 plus 4a plus 2b plus 1 should give us 9. And 4a plus 2b would be equal to 0. So this is the first equation. And the second equation coming from this, p of 3 being equal to minus 19, we're saying minus 3 raised to the power of 3, then plus a times minus 3 squared, plus b times minus 3 plus 1 should give us 19. And minus 27 plus 9a minus 3b plus 1 should give us 19, such that 9a minus 3b is equal to minus 26. 19 plus 26, 19 plus 26, this will give us 45. So this should be equal to 45. And of course, if we factor out 3, we get 3a plus 3a minus b is equal to 15. So this is the second equation, right? So we're going to use these two equations to solve for a and b, and we can do that simultaneously using the substitution method. Because here we can simply make b subject of the formula to get b is equal to 3a minus 15, and we're now saying 4a plus 2 times 3a minus 15 should give us a 0, and 4a plus 6a, right, is equal to 30, and 10a being equal to 30, this implies that a is equal to 3. And when a is equal to 3, we're saying 3 times 3 minus b, we're simply saying b is equal to 3 times 3 minus 15. 9 minus 15, we get a minus 6. So b is equal to minus 6, and a is equal to 3. So these are the two values of a and b that we get for number 2. So now let's move on to number 3. Okay, so now for number 3, we're told that when 6x squared plus x plus 7 is divided by x minus a, the remainder is equal to the remainder obtained when the same expression is divided by x plus 2a, where a is not equal to 0. Find the value of a. So we're saying in this case, when divided by x minus a, we have f of a, right? This is equal to the remainder that we get. This should give us the remainder that we get. And we're told that the remainder that I'm going to get is equal to the remainder obtained and divided by x plus 2a. So this is equal to when f equal to f of, in this case, if we say x plus 2a is equal to 0, x will be equal to minus 2a, like this. And I'm just making this expression be our f of x. So in this case, our f of x is 6x squared plus x plus 7, right? So now f of a is equal to f of minus 2a, and this is how we're going to solve for a. So f of a, we're saying 6a squared plus a plus 7, 6a squared plus a plus 7 is equal to 6 times minus 2a squared plus minus 2a plus 7, which will give us 6a squared plus a, 6a squared plus a plus 7 being equal to 24a squared minus 2a plus 7. And if we take what's on the left hand side to the right hand side, we've got 0 being equal to 24a squared minus 6, 24a squared minus 6a squared, that will give us 18a squared, and minus 2a minus a, that will give us minus 3a, then 7 minus 7, that will give us 0. Says that now we can factor out 3a to get a minus, to get 6a, let me write this properly, to get 6a minus 1 being equal to 0. And you can say either 3a is equal to 0 or 6a minus 1 is equal to 0. And here we get a is equal to 0 or a is equal to 1 over 6. But it is specified, right, that a cannot be equal to 0. So we shall discard the solution and take the solution that a is equal to 1 over 6. So this is the value of a that we get after we solve for a. Okay, so this was looking at the remainder theorem and how we apply the remainder theorem. So please, if you're new to my channel, don't forget to subscribe and feel free to leave a comment, drop a like and share. Thank you.